Hi everybody. So in this video, I'm going to show you how we can use Euler's method to solve first order differential equations. And this refers to using this equation here. So in the first example, I'm going to show you how we can derive this equation from this graph, and then we'll use this to solve question B. And then at the end, we'll work through an exam style question. And if you want to work along with me in this video, you can download a copy of a PDF from my website. I'll leave a link in the description below. So to derive this equation, first thing we're going to do is we're going to draw a line segment between the two given points, xo and x1. Then we can work out the gradient of this line segment, which will be delta y divided by delta x. And this will equal the change in y, so y1 minus yo, divided by the change in x, so x1 minus xo. And we're told here that the change in x is h. So this means that we've gone from xo to x1 by moving across by h, where h is small. So we'll say that delta y divided by delta x will be y1 minus yo divided by the change in x, h. Now as h tends to 0, so as h becomes very, very small, delta y divided by delta x becomes dy by dx. And then we can move this h on the right-hand side to the left-hand side, and this will equal y1 minus yo. Then all we need to do is to move this negative yo to the other side, so we get y1 will equal yo plus h times dy by dx. And this will allow us to find the y value at this point using the gradient. But what if we wanted to work out a different y value? For instance, this one or the one up here. Well, we can work out y2 and y3 using an iteration formula. So we can think of y1 as being our next y value, so yn plus 1. This will equal yo, our current y value, yn, plus h, the distance we've moved along in the x-axis, multiplied by the gradient dy by dx at that current iteration. So this is Euler's method for solving first order differential equations numerically. And I'll show you how this works using question B. If we're given that y equals x squared, then we know dy by dx will be equal to 2x. We just differentiate the x squared with respect to x. We've been given that when x equals 1, y equals 1, and that we're moving across in the x-axis 0.1 for every iteration. So if we have our iteration n, then we have the x value at that iteration, xn. We'll have the y value at that iteration, and then we'll have the gradient dy by dx for that iteration. And we're told originally when n is 0, x is 1 and y is 1. So we can substitute 1 into here. And we can work out dy by dx at this point by substituting x equals 1 into our gradient function, and we get 2. So for our second iteration, we're moving across by 0.1 in our x direction, so this will be 1.1. We can work out the gradient at this point. We'll substitute the 1.1 into here, and we'll get 2.2. So using this equation, y1 will be yo, which is 1, plus h, so 0.1, times dy by dx when n is 0. And we'll just work this out as 2. So we've got 1 plus 0.2, y1 will be 1.2. So for our second iteration, we're going to go across another 0.1 Now we'll have x equals 1.2. We can work out the gradient at this point. We'll substitute the 1.2 into here, and we'll get 2.4. So now y2 will be the previous y value, which is 1.2, plus h times the previous dy by dx, which is 2.2. We can work this out and we get 1.42. So this will be our y2, 1.42. And for our third iteration, when x is 1.3, we can work out dy by dx. We'll substitute 1.3 into here. We'll get 2.6. So y3 will be the previous y value, 1.42, plus the 0.1 times the previous gradient of 2.4. We can work this out and we get 1.66. And then when n is 4, we know the x value will be 1.4. The gradient at this point will be 2.8. We're just doubling this from here. So y4 will be the previous y value, 1.66, plus h, lots of a previous gradient of 2.6. And this will give us 1.92. And we can check the accuracy of this 1.92 by substituting in the 1.4 into the original equation for y. So y will be 1.4 squared, and this works out as 1.96. So you can see it's a good approximation. Okay, let's try the exam style question. Okay, so in our exam style question, we've been given that the function y of x satisfies this differential equation, where when x is 2, y is 1, we've been asked to use Euler's method, given here, with h as 0.1 to obtain an approximation to y when x is 2.3. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had to go. So the first thing we're going to do is to draw the table. So we've got our iteration, n. We've got the x value at that iteration, xn. We've got yn, and then the gradient for that iteration. So if I just create this into a table, so when n is 0, we're being told that x is 2 and y is 1. We can work out the gradient at this point by substituting these values into our gradient function. So dy by dx, when n is 0, will be the 2 squared minus the 1 squared. And this will give us 3. So for our next iteration, when n is 1, we're told that h is 0.1, so we're moving this across in the x direction. So x will be 2.1. We can work out y1 as the previous y value, so this 1, plus h times the previous gradient. And this will give us 1 plus 0.3, 1.3. This will be y1. Now we can work out the gradient at this point. We'll substitute each of these into our gradient function. So dy by dx, when n is 1, will be 2.1 squared minus 1.3 squared. And this will give us 2.72. We'll put this into our table. So for our second iteration, when n is 2, we're moving across another 0.1, so x will be 2.2. We can work out y2 as the previous y value, 1.3, plus h times the previous gradient. and this will give us 1.572. We can put this into our table. And now we can work out the gradient at this point. So dy by dx when n is 2, we'll substitute in the x and the y value. So we'll get 2.2 squared minus 1.572 squared. And this will give us 2.369. So when n is 3, we'll get x is 2.3. We can work out y3. We'll use the previous y value plus h times the previous gradient. We can work this out and we get 1.8089. Okay, so this is the y value when x is 2.3. Okay, so thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.